This is a demo video of SmartMedicineBox. Here I will introduce the structure of our IoT platform. The first one is the medicine catalog. The medicine catalog works as a catalog in the whole system. Catalog provides the information of the devices, resources, and service. User can also configure the information of the field through RESTful web service. For the device, they will get data from the catalog field through GET method, and it can update the information in its data structure. The message broker. It provides an asynchronous communication based on the publish and subscribe approach. It applies the MQTT protocol. The Raspberry Pi connector is an implementation of the device connector that integrates into the platform Raspberry Pi box. Raspberry Pi equipped with humidity temperature sensor to provide the environment status measured in the medicine box. Two digital push buttons for interacting. LCD screen is used to display some information. Our box is divided to several places. Each place has one LED light. LED is used to inform user which medicines are needed to take. The connector works with MQTT protocol. As an MQTT publisher, it publishes the environment status every few seconds, and it publishes pricing signal when we press buttons. As an MQTT subscriber, it will control the LED light and LCD screen when it receives control commands. The next one is the core part of our IoT platform. All these four control strategies can interact with catalog server through RESTful services. The first is the pricing control. The pricing control is a control strategy that opens the box when user presses the white button. It subscribes signal from white button. If it receives the signal, it will switch the user of the medicine box, and it will publish control command to LCD screen. All light will be turned off in this case. Time shift provides information about what medicines the user needs to take at current time, and it will send a notification email if the user forgot taking the medicines. It publishes medicine data with JSON format. The key of the data is the username, and the value of the data is a list contains the medicine that the user needs to take. These information are used by quantity control. If the user does not need to take any medicines at this time, the medicine list will be empty. The next one is quantity control. It's a control strategy that records the remaining quantity of medicines. It reminds user to buy some new if some medicines will be finished. The data published by time shift is stored as dictionary. As an MQTT subscriber, it subscribes the signal from green button. If we press the button, it checks if the current user needs to take medicine at this time. If yes, it will publish control commands to LCD screen and LED lights. LED lights of the corresponding places will be turned on, and the remaining quantity of these medicines will be computed. In catalog server, the quantity information will be updated through post service. If some medicines will be finished, user will receive a notification email. The environment control monitors environment measurements and reminds user to buy some new medicines if these medicines are in critical situations, like the high temperature or high humidity. It subscribes the environment measurements from the temperature and humidity sensor. If the critical temperature and humidity affect the medicines, it will send an email to inform user to replace the medicines with new ones. The SenseSpeak is a third-party software. The environment measurements are published by temperature and humidity sensors through MQTT protocol. SenseSpeak will generate two charts. One is for the temperature and the other one is for humidity. Freeboard. Freeboard in this project is a dashboard that imports charts of the temperature and humidity from SenseSpeak. It allows users to visualize the change of the temperature and humidity. Telegram bot. In this case, we can use Telegram bot to visualize the information of user and the medicine quantities through GET service, and we can also to replace medicines through POST service, and the information stored in the catalog server will be updated. The web page consists of several sub-web pages. User can use the web page to aid user and medicine, delete medicine, and do other simple operations. If we want to know some underlying details, it's possible to use web pages for managing the platform, like to modify the IP address of the broker or manage the registered device. For supporting our SmartMedicineBox, we need to run some Python files. First, we need to run this file, which is called address server. This file is used to provide the IP address and port of catalog to users, because catalog is a server, and if it is done in some critical situation, the user needs to know the new IP address of this catalog. So first, we run this file. Okay, this file has already run. The next, we need to run the file of catalog. After that, we need to run some file about configuration of the sensors which are connected to the Raspberry Pi. First, the file is about the digital button. And then the temperature and humidity sensor. The LCD screen. And the light. Next, we need to run some important modules in our project. The first one is the environment control. This file is used to monitor the temperature and humidity in our medicine box, and it will send emails to users if the environment situation in the box is in critical situations. So we need to run these modules for monitoring our environment data. The file pressing control is used to control the box. It can receive the signal from the white button, which is used to switch the current user. And when the user is switched, the light will be turned off. The next module is called time shift. This module is used to publish periodically about the medicine schedule of the medicine box. It will provide the information that the user need to take which medicines in this time. So it's really important part, and it will provide information to the next module, which called quantity control. In quantity control, it will receive the message which published by time shift, and it will save the information of the medicine schedules. And next, it can also receive the signal from the green button. If the user presses the green button, and it will check if the user needs to take medicine at this time. If yes, the quantity will be reduced and the light will be turned on. Here we introduce the web page of our Internet of Things project. First, we run the code. We can see that in this web page we have several sections. Usually, if you are a user, you can manage some basic information like the user, the medicine, and you can manage the quantity of one medicine. But if you want to know some underlying information, you can go this part. In this part, you can get information like the IP address and the port of the broker. You can get the devices. You can get the quantity of the temperature threshold of the medicines. Or you can also add or delete something, and you can interact with the catalog field.